Everyone's interested in clean energy solutions these days, right? It feels like we're always looking for that one energy source that'll solve everything,
Yeah,
that magic bullet.
for sure.
So what if I told you there might be something out there so abundant and powerful it could completely change the game? It's called zero-point energy.
Zero-point energy, or ZPE, is a fascinating concept.
Okay.
It's the energy that exists at the very foundation of the universe,
Wow.
even in the absence of matter.
Really?
It's tied to this idea of the quantum vacuum, which, unlike the classical vacuum we might think of as just empty space, is actually teeming with virtual particles.
Okay, you've piqued my curiosity.
Right.
This quantum vacuum sounds a bit like something out of Star Trek.
It does have a certain sci-fi ring to it. Essentially, the quantum vacuum is a space where particles are constantly popping in and out of existence, governed by the laws of quantum mechanics.
So it's not really empty space at all.
No, not at all.
What's going on down there at that quantum level?
It's all about uncertainty. One of the fundamental principles of quantum mechanics is Heisenberg's uncertainty principle.
Right.
It states that you can't know both the position and momentum of a particle with perfect accuracy at the same time.
Got it.
This inherent uncertainty leads to fluctuations in the vacuum,
Okay.
creating these virtual particle pairs.
It sounds like a constant dance of creation and annihilation.
Yeah, it really is.
So how does this relate to zero-point energy, and could this be the clean energy breakthrough we've been waiting for?
Well, these fluctuations, these fleeting appearances and disappearances of particles, generate a background energy that permeates the universe. Even at absolute zero, the lowest possible temperature,
Oh.
that's zero-point energy.
Okay.
And yes, the idea of tapping into this vast, ever-present energy source is incredibly enticing,
Yeah.
especially as we seek clean and sustainable alternatives to fossil fuels.
So it's clean, abundant, and always available. That's a pretty compelling case.
It is.
But how realistic is it to actually harness this energy? Are we talking about something that's decades away? Or is there tangible progress being made?
Well, it's definitely not as simple as just plugging into the quantum vacuum.
Huh.
One of the biggest hurdles is figuring out how to extract energy without disrupting the delicate balance of the vacuum itself.
Oh, I see.
But there are glimmers of hope.
Okay.
One piece of evidence suggesting ZPE might be within reach is the Casimir effect.
The Casimir effect. I remember reading something about that. Refresh my memory.
Imagine two uncharged, perfectly conducting plates placed very close together in a vacuum.
Okay.
The Casimir effect predicts that these plates will experience a force pushing them together.
Oh, wow.
This force arises from the difference in zero-point energy density inside and outside the plates.
Interesting.
It's a tiny effect, but it's measurable, and it demonstrates that the quantum vacuum isn't just a theoretical concept. It has tangible consequences.
Okay, that's pretty amazing. So manipulating the boundaries of this quantum vacuum is a potential way to tap into zero-point energy.
Potentially, yes.
Are there specific research projects or approaches that are particularly promising?
There are some researchers exploring the use of metamaterials, which are artificially engineered materials with properties not found in nature,
Okay.
to potentially manipulate the Casimir effect and extract energy from the vacuum.
Wow.
However, this is all still very much in the early stages of research.
This is all incredibly complex.
It is.
But I'm starting to understand the possibilities here.
Good.
But if we could somehow crack the code, what would that process actually look like?
Right.
How do we go from these theoretical concepts to actually harnessing and using zero-point energy?
Well, let's imagine for a moment that we figured out how to safely and efficiently extract ZPE.
Okay.
The next step would be to develop the technology to control and utilize that energy.
All right.
This is where things get really interesting, where we might need to stretch our imaginations a bit.
I'm ready to stretch. Let's dive into the hypothetical world of ZPE technology.
Okay.
What kind of systems are we talking about?
One of the key challenges is that the quantum fluctuations we've been talking about are incredibly chaotic.
Right.
To extract usable energy, we need to find a way to make those fluctuations more organized.
So it's about bringing order to the chaos.
Exactly.
Like taming a wild beast of energy.
That's a great analogy.
Uh-huh.
This process of making the quantum fluctuations more organized and predictable is called coherence.
Okay.
It's like taking a wild ocean of energy and turning it into a controlled flow, something
Yeah.
we can actually harness and utilize.
I see.
And that's where the concept of a coherence engine comes in.
A coherence engine. Okay, now we're really venturing into sci-fi territory.
Uh-huh.
What would a coherence engine actually do?
A coherence engine would be the heart of a ZPE extraction system.
Hmm.
It would use precisely tuned electromagnetic fields and potentially even exotic materials to align those chaotic quantum fluctuations,
Are you?
creating a more coherent state from which energy could be extracted.
So it's like a conductor leading an orchestra, bringing harmony to the quantum world. But how do we make sure everything stays stable during this process? The quantum world is notoriously delicate, and we don't want to accidentally cause any, well, unintended consequences, right?
You're right, stability is crucial.
Yeah.
To ensure safe and controlled energy extraction, we need incredibly sensitive monitoring systems.
Okay.
Think of them as quantum sensors,
Yeah.
constantly watching for any signs of instability or decoherence, which is the process of those organized quantum fluctuations reverting back to their chaotic state.
So they're like the guardians of the quantum realm, making sure everything stays balanced. What kind of technologies are we talking about for these sensors?
These quantum sensors would need to be able to detect even the slightest shifts in energy density or changes in the coherent state.
Hmm.
This might involve using advanced techniques like quantum entanglement or superconducting circuits to achieve the required level of sensitivity.
It sounds like we'd need to push the boundaries of materials, science, and engineering to make this work. And even if we manage to extract this energy, we still need to figure out how to store it and convert it into a usable form,
That's right.
right? We can't just plug our houses into the quantum vacuum.
Exactly.
So how do we go from raw quantum energy to something we can actually use?
All right.
What are the next steps in this hypothetical ZPE system?
Well, let's explore that next.
Yep.
The technology we're talking about would need to capture, convert, and store this energy efficiently.
Right.
It will require a whole new level of innovation, and it'll be fascinating to see how these ideas evolve as our understanding of the quantum world deepens.
So before the break, we were talking about the mind-boggling possibility of extracting energy from the quantum vacuum.
Right.
You mentioned that even if we manage to achieve coherence and safely extract this zero-point energy,
Yes.
we still need to figure out how to store it and convert it into something we can actually use.
We do.
Tell me more about this next stage.
Well, you're right. We can't just plug our devices directly into the quantum vacuum. We need a way to capture, convert, and store this energy efficiently.
Right.
And to do that, we need to develop some truly groundbreaking technologies.
All right, let's talk tech. What kind of systems are we envisioning to handle this zero-point energy?
One of the key components would be something called a fractal energy collector.
Okay.
Now remember, this is all hypothetical, but the idea is fascinating.
Yeah.
These fractal energy collectors would be nanoscale devices designed to interact with the coherent quantum fluctuations and channel that energy into a usable form.
Fractal energy collectors. The name alone sounds futuristic, but what makes them so special? Why fractal?
The fractal part refers to their design.
Hmm.
They would be built with intricate repeating patterns at the nanoscale,
Right.
kind of like a highly complex antenna.
Okay, so like an antenna tuned to a specific frequency,
Yes.
but for zero-point energy, how would that actually work?
Think of it this way. Each of those tiny repeating patterns within the fractal structure would be designed to resonate with a specific frequency of the coherent quantum fluctuations.
Okay.
And by resonating with those frequencies, they could effectively capture and channel that energy.
So it's about matching the vibrational frequency of the quantum vacuum, and that's amazing.
It is.
But once we've captured this energy, how do we transform it into something we can use to power our homes, our cars, our lives?
That's where the conversion process comes in.
Okay.
We need to take this raw quantum energy and convert it into electricity, the lifeblood of our modern world.
Right.
And one potential way to do that would be through the use of superconductivity.
Superconductivity, I've heard of that. It's something to do with zero electrical resistance, right?
Exactly.
How would that play a role in ZPE conversion?
Superconducting materials allow for the flow of electricity with absolutely no energy loss to heat.
Got it.
So imagine a system where the energy captured by the fractal energy collectors is channeled through superconducting circuits, converting it into a steady stream of usable electricity.
It sounds incredibly efficient. No energy wasted, just pure, clean power.
It would be amazing.
But we can't just use all this energy as soon as we generate it.
Right.
We need a way to store it for later use, right?
Yeah.
What kind of batteries could possibly handle that kind of power?
That's where the concept of quantum batteries comes into play.
Okay.
Now remember, we're still very much in the realm of hypothetical technologies,
Right.
but the idea of a quantum battery is particularly intriguing.
I'm all ears. How would a quantum battery be different from the batteries we use today?
Instead of relying on chemical reactions to store and release energy, as our current batteries do, a quantum battery would exploit the principles of quantum mechanics to store energy at the atomic or even subatomic level.
So we're talking about storing energy within the very fabric of matter itself. That's mind-blowing.
It is. And because we're working at such a fundamental level, the potential storage capacity of a quantum battery could be vastly greater than anything we can achieve with current battery technologies.
Wow, okay. I'm starting to see the bigger picture here.
Yeah.
We've got these fractal energy collectors capturing energy from the quantum vacuum,
Right.
superconducting circuits, converting it into electricity, and then quantum batteries storing it all up. It sounds like a truly revolutionary energy ecosystem.
It really does.
But before we get too carried away, let's step back and consider the practicalities.
Okay.
What are the biggest challenges we need to overcome to actually make this technology a reality?
You're right. There's a huge gap between these theoretical concepts and actual working devices.
Yeah.
One of the biggest challenges is the sheer complexity of engineering at the nanoscale. Building these fractal energy collectors with the precision and complexity required would be a monumental feat.
So it's not just about understanding the physics, it's about our ability to actually manipulate matter at the atomic level.
Exactly. And then there are the material challenges.
Okay.
We need to discover or develop new materials with very specific properties. Materials that can withstand the unique conditions involved in interacting with the quantum vacuum. Materials that can exhibit superconductivity at practical temperatures. Materials that can store vast amounts of energy at the atomic level.
It sounds like we need a revolution in materials science to go hand in hand with this energy revolution.
Absolutely. And then there are the theoretical challenges.
Okay.
While we have some understanding of the quantum vacuum, there's still so much we don't know.
Yeah.
To really master this technology, we need to deepen our understanding of the fundamental physics at play.
So it's about pushing the boundaries of our knowledge in multiple scientific fields.
Exactly. And we can't forget about the potential economic and logistical challenges.
Right.
Developing and deploying this technology on a global scale would require massive investments and a complete reimagining of our energy infrastructure.
It's clear that there's a long road ahead before zero-point energy becomes a reality.
I agree.
But the potential benefits are just so tantalizing. It's hard not to get excited about the possibilities.
It is exciting.
Yeah.
Imagine a world where clean, abundant energy is available to everyone everywhere.
Wow.
No more fossil fuels, no more pollution, no more energy poverty.
Yeah.
It's a vision worth striving for.
Absolutely. But as with any powerful technology, we also need to consider the potential risks, ethical implications.
Oh, sure.
And that's a conversation we need to have as we explore this fascinating frontier of science.
You're absolutely right.
Yeah, zero-point energy has the potential to change the world, but it's important to approach it with both enthusiasm and careful consideration.
I agree.
We need to ask ourselves not just, can we do this, but also, should we do this? And how do we do it responsibly?
Those are crucial questions.
They are.
And they lead us to the final part of our deep dive into zero-point energy, where we'll explore the ethical considerations of harnessing this potentially limitless power.
We've been on quite a journey exploring this mind-boggling concept of zero-point energy.
Yeah, it really has been.
From the bizarre world of the quantum vacuum to these futuristic technologies we've been imagining.
Right.
It's clear that ZPE has a potential to completely transform our world.
Absolutely.
But as we've hinted at, this kind of power comes with a huge responsibility.
It does.
So let's dive into the ethical considerations surrounding zero-point energy.
Okay.
What are some of the potential risks or unintended consequences we need to be thinking about?
Well, it's crucial to have these conversations early on.
Yeah.
Any technology this powerful has the potential for both immense good and potential harm.
Right.
One of the first things that comes to mind is the risk of weaponization.
That's a sobering thought.
Yeah.
We've seen this play out with other powerful technologies throughout history.
We have.
Could ZPE be used to create weapons of unimaginable destructive force?
It's a very real concern.
Wow.
If we can figure out how to extract and control this energy, it stands to reason that someone could try to use it for destructive purposes.
All right.
Imagine a weapon that could tap into the limitless energy of the quantum vacuum.
Oh, wow.
The consequences could be devastating.
It's a chilling thought.
It is.
So what can we do to prevent this? Are there any safeguards we could put in place?
International cooperation and strict regulations are absolutely essential. We need to have open discussions about the potential dangers of ZPE technology and work together to establish clear guidelines for its development and use
Right.
treaties, monitoring systems, ethical frameworks,
Okay.
everything we can to ensure this technology is used for good, not for harm.
That makes sense.
Yeah,
But even if we manage to avoid the worst case scenario of weaponization,
right.
there are other ethical considerations, right?
There are.
Things like access equity and the potential for unintended economic or social disruptions.
You're right. We need to be thinking about the broader societal impacts of this technology.
Yeah.
For example, who controls access to ZPE?
Hmm.
Who benefits from it?
Good question.
If this technology is expensive to develop and deploy,
Hmm.
it could exacerbate existing inequalities.
Oh, I see.
We need to ensure that ZPE technology is used to benefit all of humanity, not just a select few.
It's almost like we need to rethink our entire energy infrastructure and economic models if we're going to introduce something as disruptive as zero-point energy.
Yeah, that might be necessary.
Are we ready for that kind of change?
That's a big question, and there are no easy answers.
Yeah.
The transition to a ZPE-powered world would likely be complex and challenging,
Right.
with potential winners and losers along the way.
For sure.
We need to have honest conversations about these potential disruptions and work to mitigate any negative consequences.
So it's not just about the science and engineering.
No.
It's about the social, economic, and political implications as well.
It is.
It sounds like we need a whole new field of study just to grapple with the ethics of zero-point energy.
I think you're right.
Wow.
This is a field where scientists, engineers, policymakers, ethicists, and social scientists need to come together.
Right.
It's a massive interdisciplinary challenge, but it's one we need to take seriously if we want to harness this power responsibly.
It's clear that there's a lot to consider here.
There is.
Zero-point energy holds the potential to solve some of humanity's most pressing problems,
Absolutely.
but it also presents us with a whole new set of challenges and responsibilities.
It does.
As we wrap up this deep dive, what's the key takeaway for our listeners?
I think the most important message is this.
Okay.
Zero-point energy is not just a scientific or technological challenge.
Right.
It's a human challenge.
Mm-hmm.
It's a test of our wisdom, our foresight, and our ability to work together for the common good.
Yeah.
If we approach this technology with both caution and a sense of shared responsibility, we have the potential to create a truly sustainable and equitable future for all.
That's an inspiring thought.
It is.
It's a reminder that ultimately technology is a tool, and it's up to us to decide how we use it. Zero-point energy offers us an incredible opportunity, but it also demands that we rise to the occasion and make wise choices.
I agree. The future's in our hands.
It is.
Let's make sure we use this power wisely.
Thank you for joining us on this incredible exploration of zero-point energy.
It was my pleasure.
We hope this deep dive has sparked your curiosity and left you pondering the possibilities and responsibilities that come with this potentially world-changing technology.
I hope so too.
Until next time, keep exploring, keep questioning, and keep imagining a better future.